Hello Algebra 1 students, welcome to the Unit 7 review packet. We're talking about factoring and rational expressions in this set of problems. Let's get right into it. The directions say for 1 through 8, simplify, show all work and leave your answers in a factored form for credit. So this, number 1, we can't really simplify anything here, but we can leave that or change that to a factored form. So this you could factor out, and for the sake of my class at least, we're always going to factor out a negative if the first term or the highest power term has a negative with it. So we're going to take out a negative 2, and we can also take an x out of both of those terms. So negative 2x, if you think of dividing each piece here by negative 2 and x, that's really what we're doing if we're factoring that out. We're dividing each piece by that, and what we're left with would be x, and then this would be minus 2. So this is your fully factored final answer. Negative 2x times the quantity x minus 2. For number 2, if there's a GCF, always try to take any GCF out first when we're dealing with rational expressions like this. So here I could take out a 6. I'd have x plus 6 left. And then here on the bottom I could take out a 4. I'd have x minus 15 left. And then here, if these were the same, I could cross them out, but they're not. However, this and this are the same. So I could say they're not the same, but they have a factor in common of 2. So I could divide this by 2 and this by 2. I'd have, for my final answer, 3 times the quantity x plus 6, and then 2 times the quantity x minus 15. That's a fully factored form there for my final answer. Number 3. It looks like we can cancel some things top to bottom. 5 and 25, I could cancel that out and write a 1 and a 5. And I'll write that down as I go here. I think that's a good way to approach these kinds of problems. And you look at the rest, it looks like a squared, b cubed, and c to the 4th are all smaller than what you see on the bottom there. So this would become, you got rid of 2, get rid of 2 here. Got rid of 3, get rid of 3 here. Got rid of 4, get rid of 4 there. So all of these are going to be to the first power, a to the first, b to the first, c to the first. And so your final answer in a fully simplified form, we leave off those first powers, or those powers of 1, and 1 over 5abc is your answer. It's not just 5abc. If everything cancels on the top, then you still have an invisible 1 that's there. Number 4, this one, we look for GCF first, or we look for a GCF first. Looks like I can take a 2 out of everything on the top. So this would be 2 times x squared minus 14x, not minus 14x, excuse me, minus 7x, because I'm factoring out a 2. And then plus 6. On the bottom, you can factor out the GCF is just x. Then you'd have x minus 6 left. From that point, you can do this sort of thing if that helps you. So 6 on the top, negative 7 on the bottom. The magic x, I like to call it. This would be the right combination. Negative 1 and negative 6 would multiply to 6 and add to negative 7. So you'd have 2 times, and then you could write x minus 1 and x minus 6. If you change the order and write x minus 6 first, that is okay. And then here you'd have x times x minus 6. X minus 6 will cancel there and there. Your final answer would look like this. 2 times the quantity x minus 1 all over x. Moving on to number 5. So still following these directions, we're simplifying and showing work in a factored form for credit. This looks like we can do this sort of thing with this potentially. So let's see if we can use the x, find the factors. And it looks like it would be negative 4 and negative 8. That would multiply to positive 32 and add to negative 12. So this is going to equal, you'd have k minus 4 times k minus 8. That's the numerator of this fraction. If there's a negative, factor that out. So negative in front of the first term here, and then k plus 8. If we factor a negative out of both of these, it looks like that. We're going to have that times k minus 6. I'll just include that in parentheses here. And then on the bottom, the denominator here, to have negative 24 and negative 10, looks like negative 4 and negative 6 would be the right combination there. So you would have k minus 4 times k minus 6. You've got a k minus 6 here, top and bottom, and you've got a k minus 4 on the the bottom here and on the top here, it's multiplied, so we can cancel those. If it's plus or minus, then we have to tackle that a different way. But we have k minus 8 on the top. That's different than k plus 8, so we have to keep it like this. There's no negative factored out that we can cancel out with this negative, so this would be a fully factored form for the final answer. Number 6, do the same sort of thing here. So you're going to have negative 42, and this is like a positive 1 right there. So you would have 7 and negative 6. That would multiply to negative 42, add to 1. This would be x plus 7 times x minus 6. On the bottom, here you have a negative in front of that first term. So factor it out. Take a negative out of both of those. That would become negative. This would become positive if you factor out the negative there. Do the same sort of thing with this one. So we're gonna have, x minus 9 if we take a negative, factor a negative out of both of those. And then for this one, negative 54 and negative 15, the right combination would have to be 3 and negative 18. You might think 9 and 5, or 9 and 6, I mean, but there's no way to make a negative product and a negative sum with 9 and 6. So you'd have to have 3 and 18. So this one, you could have, I'm writing k, that was the last one, so you'd have x minus or plus 3 and x minus 13 in the other spot. You could flip-flop those, you could flip-flop these, you'd still have the same thing. So there are a couple things that cancel out here. Looks like the negative signs will cancel. It looks like the x minus 6's will cancel, but it doesn't look like anything else will cancel. So we would have x plus 7 times x minus 9 on the top, x plus 7 times x minus 9. And then on the bottom, negative's gone, x minus 6 is gone. You have x plus 3 times x minus 18. Directions say to leave it in a factored form, so we don't multiply things back through, just leave it like that. Number 7, we're looking for a lowest common denominator with this kind of problem. You could use 30x, that would work. You could multiply by 5 over 5 and then 2 over 2, but there's an even lower one that would work. So I noticed that, actually, no, what am I saying? This is the lowest common denominator. I'm thinking of maybe 90x. So you could actually multiply this by 15 over 15 and this by 6 over 6 with an x attached to that one, so 6x over 6x. That's one possible way. It's a common denominator, but it's not the lowest common denominator. The lowest is always going to be the best. It's going to do that the fastest for you. So I'm going to multiply this one by 5 over 5, and then this one by 2x over 2x. I'm doing this to get a common denominator. If you're multiplying, if this was a times sign in between there, a dot in between there, we wouldn't have to deal with this, or we wouldn't have to do that. You could just multiply straight across and reduce top to bottom. However, it's subtracting here, so we need a common denominator. Whenever you add or subtract fractions, you have to have a common denominator. So if we multiply things together here, we've got 25 over 30x for that one. And here we've got negative 4 times 2 would be 8, so negative 8, and then x times x is x squared. And this would be 30x on the bottom as well there. We put things together. The denominators are the same. Now we can just add the numerators together. And there's nothing we can factor out of 25 and negative 8x squared, so there's nothing else really to do with that one. That would be a fully factored final answer for that one. Number 8, if you look at this one, it looks like we might be able to factor the bottom part, the denominator there. 24 and 10, 4 and 6 would definitely work. So you're going to have 3 over g plus 4, and then times 2g over g plus 4 times g plus 6. So if you look at this one, nothing cancels with what's on the bottom on the top. So there's nothing else to do here except to multiply things together. So 6g over g plus 4 written twice times g plus 6. That would be a final answer. So the whole thing would look like that. You could write it like that, or you could also write this. Since there's two g plus 4's, you could write g plus 4 squared times g plus 6. Both of those would be valid final answers. Number 9, now we're trying to factor completely, and this is where a does not equal 1. A, b, and c are the coefficients and the constant term for c that you see there. So 3, negative 5, negative 2. Is there a GCF first? Always look for that first. If there's not, you can't take anything out. If there is, though, like there will be with, looks like 2 of these problems here, we would take that out first. So from here, let's see what we can do. We could try a guess and check method, but I don't want you to do that if you're one of my students. I want you to show me that you know the more algorithmic way, the way that always works. You multiply the first times the last, a times c. 3 times negative 2 is negative 6, and then you put the middle coefficient on the bottom here. The right combination for that looks like it's going to be negative 6 and 1. You could also write 1 and negative 6. You could flip the order of that. But we're going to use these two numbers then. We're going to take this and split it up into 2 parts with those as the 2 parts. So you've got 3w squared minus 6w and then plus 1w minus 2. Negative 5w is the same thing as negative 6w plus 1w. So I didn't change what it equals, I just changed how it looks. Now I'm going to group together things. So I'm going to group these two together and these two together. If you wrote the 1w first, you're going to get the same answer in the end. So don't worry if you write these in a different order. If you do it right, you get the same answer. You can factor out a 3w out of both of those. You're left with w minus 2. Here you can't factor anything out except a 1 out of both of these. So you have to actually write that on these kinds of problems. So write out the 1 that you're factoring out, and then w minus 2 is still there. Since 3w and 1 are both being multiplied by w minus 2, we can put them together in its own set of parentheses. So we're going to have 3w minus 1, plus 1, excuse me, and then w minus 2. We're not solving here, so we're done. We stop right there. We box that in. We're just factoring completely. So there's no GCF I can take out of either one of those. I didn't forget it at the beginning. We're good to go. Here there's a GCF though. You can take a 9 out of each term there. So 9 and then x squared minus 2x plus 1. And if you factor this part here, if it's just a 1 in front here, then you're just thinking, okay, this would be negative 1, negative 1. So this becomes 9. You don't have to use grouping if a equals 1. You just split it up into those two terms. So x minus 1, and it's x minus 1 after that. Again, these two numbers going right here and right here. If it's just x squared or a variable squared, this is always just going to be the variable and the variable. So that is it. You could stop right there, or another valid way to write that, since there's two x minus 1s multiplied together, you could say 9 times x minus 1 squared. So I would take either one of those as acceptable answers. For number 11, we have to have the x squared part first. So we got to write this in standard form, descending order of the powers. Negative 6x squared minus 13x minus 6. And then I always want you to keep your x squared part positive. So we're going to factor out that negative. We don't want to deal with a negative when we're trying to do grouping and things like that. So we're going to take that negative out, and then we would say negative, and then in parentheses 6x squared. We take the negatives out. It's going to change all of them to positive in this case. There's nothing else we can factor out except a negative. So now we're going to multiply a times c. 6 times 6, that goes here, and then b, middle term, goes there. We would have 4 and 9 if we factor that out. So you're going to have 6x squared. This splits up into 4x and 9x. So we can write plus 4x plus 9x. You don't have to show the arrows, just trying to help you understand. And then from there, grouping. So put these two together, put these two together. You got negative, and looks like you can take out of these ones, I'm going to make a big parentheses here. You can take out 2x out of both of those. And then you'd be left with, if you divide each part by 2x there and there, you got 3x plus 2. And then this one, you can take a 3 out of both of those. So 3, and it would be 3x plus 2. If you get the same thing here and here, that's a good thing. That's what we want to happen. That means you probably did it right. So this would be 2x plus 3 together. Both of those things are being multiplied by 3x plus 2. The negative factored out. All that together is your final answer. Number 12, standard form. We want to write the x squared part first, and then the x part, and then the constant term. From there, look for a GCF. There is one. It's 4. So you take out a 4, you've got 3x squared plus 4x plus 1 left over. From there, work on your factoring. So 1, and not 1. What am I saying there? Usually it's 1 if this is 1, but it's 1 times 3 in this case. So 3 and 4. So what numbers multiply to 3? Well, just 1 and 3 would do that. And that's the combination we want, because we want them to add to that number, add to 4. So we can split 4x up into, if I read it the order I have here, I'd have 1x plus 3x. If I wanted to flip-flop those, that would be totally fine as well. But if I read it like this, I'll group these two together, group these two together. Looks like we can only take an x out of these two. So x and then 3x plus 1. And then with these two, you can't factor anything out besides a 1. So 1 times 3x plus 1. But again, that's a good thing. If this is the same as this, you're going to have 4. And then you're going to have x plus 1 together. And then 3x plus 1 are also going together. So that would be a fully factored final answer. 13 through 18, we're supposed to solve for the variable. The nice thing about 13 is if the denominators are already all the same, when you're adding and subtracting fractions, that makes it really easy, because we can just say if they're all the same, the numerators, what's left on the top, has to be equal to each other to make this a true statement. So you have 3x minus 4x equals 9x plus 30. This would become negative x equals 9x plus 30. And you could subtract 9x. This is one way about it. You'd have negative 10x equals 30. Then you could divide by negative 10 and say that x equals negative 3. To check that, you could simply take that and plug it back in, make sure it works. Number 14, it looks like we don't have a common denominator here. So we can't cross anything out yet. We would need a common denominator first. So I could multiply this all by certain things to get, it looks like 12x would be the lowest common denominator. So if I multiply this one by 2 over 2, this other one by x over x, and this final one by 3 over 3, that should do it for me. This would be 5 times 2, 10 over 12x. This one, 7 times x would be 7x, and we got a minus sign there. So that's 12x. And this would be 33 over 12x. Now they're all the same. Now you can cross them out and just think of what would make the top, the numerators here, equal to the numerator there. So if you subtract 10, you'd have negative 7x equals 23. And then if you divide by negative 7, this one you end up with a fraction. X equals negative 23 over 7. If you wrote that as a mixed number, that would be negative 3 2/3. I would leave it either as a mixed number or, more preferably, an improper fraction. Don't give me a rounded decimal unless you're told that that's okay. Number 15. No common denominator yet here. We are adding and solving, so we're going to need to get that common denominator before we can cross anything out. So always look for a GCF if there is one. Here there is. You can factor out a 3 and it looks like that. This one you've got 7 over x plus 2. Nothing to do, or nothing that you can do with that one. I'm going to leave a little blank space there because I'm going to multiply by something right there, it looks like. And then this, looks like I could factor out a 3 out of everything, but really I'm just focusing on trying to get the denominator to be the same here. So the same here as it is over here. Negative 12 and negative 4, The right combination there would be negative 6 and 2. So you'd have, I'm just going to rewrite the numerator, but then I'm going to have the denominator as x minus 6 times x plus 2. So what's missing in this one that I have somewhere over here would be the 3, just the 3. So I'm going to multiply this one by 3 over 3. This one's missing a couple parts. This one has the x plus 2, but you're missing x plus 6, or x minus 6, excuse me, and you're missing the 3. So this one's a little tricky because of that. You have 3 things multiplied together, and then this one's missing the x plus 2 factor. So all that said, look here, look here, look here. The denominators now are all the same. It's all 3 times x plus 2 times x minus 6. They're in different orders, but that's okay. So we can cross out all the denominators at that point. Then we're just solving the top. So let's make sense of what's left. You've got 2 times x plus 2. That's what's left here. You've got, this would be 7 times 3 would be 21 times x minus 6. And then here you've got 3 times 3x plus 6. So if we start to work that out, we want to distribute the 2, the 21, and the 3. We're trying to solve for x here. We've got 2x plus 4 plus 21x, and that would be minus, it looks like 126. 3 times 3x is 9x. 3 times 6, you got 18. This would be 23x minus 122 if you combine like terms. And then you could subtract 9x from both sides, and you could add 122 to both sides to get the x's on one side. That would leave you with 14x equals 140, and then if you divide by 14, you've got your answer. X equals 10. Number 16, you're still following those directions to solve for the variable, but this one we need to do that factoring, potentially where a does not equal 1. Could you use actually the quadratic formula here as well, since the directions don't specify? Sure, you could. If factoring doesn't work, that's the approach we're going to take. But it looks like you can factor a 4 out of everything, so I'm going to start with that. So I'm going to take out a 4, and I'd have this left over. That equals 0. From there, it should be pretty easy to come up with the combination, I hope. So 10 times 10, that's 100, and you add it together, you get 20. You've got 4, and then n plus 10 times n plus 10 then. Since this is just n squared, it's just a 1 in front of there, we factor out the 4. So the a value is 1. It's just going to be n times n, and then these are your factors. So this equals 0. That happens when either this is negative 10 or this one is negative 10. Both those would give you the same thing. If it helps you to write out the equation, so you're saying n plus 10 could equal 0, or another n plus 10 equals 0. So feel free to write that out if it helps you. Not something I need to see, but you could do that to get your answer. So you actually have what's called a double root there. You've got negative 10 showing up twice. Number 17. Well, we would need to, with quadratic formula or factoring, we need one side equal to 0. So I'm going to add 5x squared to both sides. That should do that most efficiently for me. So 0 on the left side, and then I want to write this in a standard form order. 5x squared minus 2x minus 16. So from there, you could use quadratic formula, but if factoring works, it might save you a little bit of time. So let's try factoring. 5 times negative 16, that'd be negative 80, and then negative 2. It looks like it's going to work because you've got negative 10 times 8 would give you the right combination there. So this would be 0 equals, and then you split that middle term up into 2 parts, just like we did back here with 9 through 12. So we're doing the same thing we did here, except now it actually equals something. Now we're solving. So you've got minus 10x plus 8x if you write them in the order they are here. Again, these could be flip-flopped, and you're going to get the same answer in the end if you do it right. So grouping, put these two together, put these two together. You can take out a 5x out of these two. You're left with x minus 2. You can take an 8 out of those two. You're left with x minus 2. So this is 5x plus 8 times x minus 2. And from there, you can either just look at it and say the opposite of that divided by the coefficient there. So negative 8 over 5. Or you could say, for that one, 2 minus 2 would make that 0. If it helps you to write that out, that 5x plus 8 equals 0 and x minus 2 equals 0, please do that. So if that is going to help you get the answer correct, don't be afraid to show a little extra work there. So if you add 2 here to both sides, you'll have x equals 2 that way. So what makes each factor 0? You can solve it like that, or you can use the shortcuts like that. And then number 18 looks like we could subtract p from both sides. We'd be left with 12p squared minus p minus 35 equals 0. No GCF there that we can factor out. So you could either go to the quadratic formula or see what would work here. So if you multiply this times this, you're going to get negative 420. And then this is like an invisible 1 right here. So if you want to write that in, for now you could. But what would give you the right combination there? Looks like 20 times 20 would be 400. So 20 times 21 would be 420. And to make it negative, both here and here, the 21 would have to be negative. So from there, you could split up negative 1p into those two values. 12p squared plus 20p minus 21p minus 35. That's the same thing as what you just had there, just with that split up into those two terms. From there, grouping will work wonders. You're going to factor out 4p out of both of those. Be left with 3p plus 5. Here you can factor out a negative 7 out of both. You're left with, well, look at that, just what we wanted. 3p, excuse me, not p, but 3p plus 5. And then from there, you've got 4p minus 7 times 3p plus 5 would equal 0. You can use your shortcuts from there. You'd say the opposite of that is 7 over divided by that number, 4. And then here, so that's 7 over 4. Here you'd have the opposite of this number, negative 5, divided by that number, 3. And again, if it helps you to write it out, please do not hesitate to do that. So you could say 4p minus 7 equals 0, solve that for p. 3p plus 5 equals 0, solve that for p. So add 7, and then divide by 4. So same answer, with or without the shortcut. Subtract 5 here, and divide by 3. P would equal negative 5/3. 19 through 22, we're doing some simplified radical form. So you can either use what I've been calling the GPS way, the greatest perfect square way, or the factor tree way. So I'll show you both here, at least with this one initially. So you can use the factor tree way. You could have 6 and 8. That would be one possible combination. You could say 2 and 3 from there, and 2 and 4 from there. 2 is prime, 3 is prime, so I'm done with those numbers. 4 you could break down more, though, into 2 times 2. So this would be the same thing as 2 times 2 times 2 times 2 times 3. Any pairs can come out. So there's a pair of 2s. The square root of 2 times 2 is 2. And you have another 2 times 2. So the square root of another 2 times 2 is another 2. And then there you've got 3. So 2 times 2, that's 4. The GPS way, I'll do that in green. The shorter way, if you realize it, you look for the greatest perfect square that's a factor of that. 16 is the greatest perfect square that's a factor of 48. Then that means you can take the square root of 16, take it out. It's a 4. So you get the same answer that way. Just takes you a little less time. Number 20. Looks like you could break that down. If it's even, you could at least start with that. So it looks like 2 times 96 would work on this one. You could break that down into 2 and 48. And it looks like 48 we could break down the same way we had before. So this would be, I could go 6 and 8. So I could go 2 and 3, 2 and 4, and a 2 and a 2. So we've got quite a bit going on this one, or quite a few factors. You're going to have 1, 2, 3, 4, 5, 6 2's actually on this one. So 3, 4, 5, 6, and then 1, 3 after that. You've got 3 pairs of 2s, so you're going to have 2 times 2 times 2, 3 2s on the outside. The pairs come out as a single 2. So you've got that, and 2 times 2 times 2 is 8 times the square root of 3. If you use the GPS way, the greatest perfect square way, the square root of 192, the greatest perfect square that divides evenly into that is 64. So you could take out 64, the square root of 64 is 8. That would get you the same answer there. So just 2 different ways to do the same thing. For 21, looks like I could split that into 2 and 49. 2 is prime. 49 is not, though. I could do 7 times 7. 7 are both prime. So this would equal 3 is still hanging out on the outside. I'm not going to do anything with that. I'm not going to touch that 3. I'm just dealing with the stuff inside the square root. I've got a pair of 7s, so the pair comes out as a single 7. It's going to get multiplied by the 3 that's already out there. You're going to have 21 times the square root of 2. The GPS way, greatest perfect square way, this would become 3, and then 49 is the greatest perfect square. That's a factor of 98, so you could have 49 times 2. 49 square root of that is 7, so you've got 3 times 7 times the square root of 2. That's 21 times the square root of 2 that way as well. And then 128. Well, you could do 2 and 64. You could break that into 2 and 32, break that down. You've got 2 and 16. You've got 2 and 8. You've got 2 and 4. And you've got 2 and 2. So on this one, you have 7 2s. That's a lot of 2s, but you get 7 2s. So 2 times 2 times 2 times 2 times 2 times 2 times 2. There are 3 pairs of 2s. One pair comes out, another pair comes out, and the third pair comes out. And you're left with just a single 2 in there. So this is going to equal 2 times 2 times 2. That's 8 times the square root of 2. The GPS way, greatest perfect square that's a factor of 128 is 64. So 64 times 2, you can take that out as an 8 and you'd be done. And then moving on to the last batch here, 23 through 26, we're going to use the quadratic formula. So the quadratic formula is, you ready for a song? I think you are, yes. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Memorize that formula. Know that little song. If that helps you memorize the formula. We're going to use this formula for each one of these. In order to use this, one side needs to equal 0, and you have to have your standard form. You have to have the x squared part of the variable squared, then the variable, then the constant term. Ax squared, bx, and c. So on this one, you've got an invisible 1 right here. Your a is going to be 1, your b is going to be negative 17, and your c is going to be 70. It's actually possible to use factoring to solve this one, but if you're following the directions, you're not going to do that. You could use factoring to check your answer, but we're going to use quadratic formula to initially get our answer, following the directions. So negative b is negative 17, the opposite of negative 17. B squared, you've got negative 17 squared, minus 4 times a times c looks like that. All over 2 times a, all over 2 times 1. This is going to become 17. This would be 289. Negative times a negative would become positive. Negative times a negative here, you've got 2 negatives multiplied together. That's going to be plus 280. And that is all divided by 2 right there. So from there, we're going to simplify. We're going to combine like terms there. Here's a mistake I just noticed I made. What's the mistake I made? This is a positive 70, so that should be a positive 70 right there. I was feeling like something was off there. So this would be 70, and this would be minus 280 then instead. That's going to make this 17 plus or minus the square root of 9, putting those things together, over 2. Square root of 9 is 3, so you have 17 plus or minus 3. Take that literally, you've got 17 plus 3, that's 20, over 2, that's one option. The other option is 17 minus 3 over 2. So you have 14 over 2. That's your second option. This would give you 10, and this would give you 7. If you were to use factoring on this, I'll just show you what happens here. So if you did factoring with negative 70, positive 70, excuse me, and negative 17, you could have a negative 10 and a negative 7. So this initial equation could actually factor to x minus 10 times x minus 7 equals 0. What would make it true? Well, 10 or 7. So I don't need to see that work. I don't want to see that work. If that's the only work you're showing, you're not following directions. But if you show it or just work through it just as a way to check your answer, that's fine. But I need to see this work. The blue stuff needs to be there. All right, 24 looks like it's not equal to 0. One side not equal to 0 yet. So if you add 20n to both sides, that'll do that for you. And everything looks like it'll be positive there. This one, it's actually possible to come up with a combination once again for 96 and 20. It would be 8 and 12. So we're going to expect our answers to be the solutions, the opposite of the factors, negative 8 and negative 12. But let's see, using the quadratic formula, that works. So now instead of x equals negative b, we're going to use n because that's our variable. But n equals negative b, n equals negative 20, plus or minus the square root of b squared, 20 squared, minus 4ac. A is 1 right there. So a is 1. That's an invisible 1 right there. Your b is 20. Your c is 96. So 96 all over 2a, 2 times 1. You got negative 20 plus or minus the square root of 400, and that's minus 392. I'm sorry, not 392, 384, excuse me, all over 2. This would be negative 20 plus or minus the square root of 16 over 2. That's going to be negative 20 plus or minus 4 over 2. And then take that literally again. Negative 20 plus 4 is negative 16. Negative 20 minus 4 is negative 24. So just as we expected, the factors here, the solutions are the opposite of those. Negative 8, negative 12. The solutions using the quadratic formula, same thing. Negative 8s or negative 12. On 25, looks like we got to get one side equal to 0 here first. And I'm going to subtract j squared. I'm going to add 18j. And I'm going to subtract 10. I'm going to get the left side to equal 0 this way. So this cancels. It cancels. That cancels, that cancels. So you've got 0 equals 2j squared plus 30j minus 32. So one thing you could do here, you could actually divide everything by 2 or factor out the 2 and then think of the GCF as a 2, then that's what you're doing. And then you could divide everything by 2 and you'd have j squared plus 15j minus 16. You could solve that using the quadratic formula as well as this. But I'm going to use just what's here. I'm going to say I didn't notice that I could have divided everything by 2. So I'm going to use this as my A, this is my B, this is my C. So if you do that, you've got j equals negative b, negative 30, plus or minus the square root of b squared minus 4ac all over 2a. So you've got this. You've got those numbers there. You've got negative 30 plus or minus, that'd be 900. This would be negative 8, and then times negative 32. That's going to be plus, looks like that's going to be 256, yes. So 256 all over, let's make that 6 look a little nicer. That's better. All over 2 times 2, which is 4. So you've got negative 30 plus or minus the square root of 1256 all over 4. The square root of 1256 happens to not be a nice number here. So this one, you have to follow these instructions, rounding to the nearest hundredth if necessary. So this one, if you use a calculator, I did this work before, so I've already figured out that negative 30 plus the square root of 1256 divided by 4 is about 5.44. This is an approximation, so I'm going to make that a little squiggly equal sign there. You have this, or negative 30 minus the square root of 1256 over 4 is about negative 16.36. That's rounded to the nearest hundredth, the nearest 2 decimal places. And then for number 26, got to get one side equal to 0 to use the quadratic formula. So I'm going to do that by adding 40x squared to both sides. 40x squared then minus 32x plus 6 would equal 0. And you could do some factoring. You could factor out, it looks like a 2, and then you could divide everything by 2. You'd still have 0 divided by 2, it'd still be 0. So that would give you 20x minus 16x plus 3 equals 0. So that would make it a little easier to deal with the numbers, but this really isn't that hard to deal with. They're that much harder to deal with using numbers that are twice as big for A, B, and C. So I'm going to just go ahead and use those as my A, B, and C. Got x equals negative b, the opposite of negative 32, plus or minus the square root of b squared minus 4ac all over 2a. So you have that when you work that out. This is going to be 32 plus or minus, and then 32 squared, that's 1024. 4 times 40 is negative 160, and negative 160 times 6, that's going to be negative 960. This is all over 2 times 40, all over 80. So you've got 32 plus or minus, and this looks like it becomes 64. That's going to work out nice for us. They don't always work out nice, like here, they don't always work out nice, but you're going to have this one, 32 plus or minus 8 over 80. That would give you 40 as the plus option, and it would give you 24 for the minus option. This is going to be 0.5 or 1/2. You could say either one of those things. And this one is going to be, if you reduce that, you could divide 8 into both of those 3 times and 10 times. So you could say 0.5 or 0.3. Or you could write it as simplified fraction 1/2 or 3/10. Either one of those would be a viable final answer. So that does it for us. Go back and review any of the problems that you need to. A great recommendation is to print out, if you're one of my students, print out a blank copy of this review packet after you've tried it yourself. Try it, go through it again. See if you do better. Keep doing it. Keep printing out new copies until you really got it down well. If you can do well on this packet and the problems you see here, you should be able to do quite well on the test. If you're one of my students, let me know if you got any questions in class. Come by before or after school. If you notice any mistakes, please comment in the comment section. Let me know if you're one of my students. You'll get some extra Wagner bucks for that. Hope you have a great day. Study hard. Do your best. Practice multiple problems. Go back and review homework and notes, as well as the other review that we've done along with this. So make sure you're ready. Be as prepared as you can be for the test. Hope you have a great day, and I'll catch you later. Bye-bye.